Today we're going to talk about the Big Tree Tech Octopus Max EZ version 1.0. Now I'm not going to jump into too much detail on the basics of this board because it's brand new, but let me point out that it has 10 motor steppers. Now these are the EZ version, so you don't have to move jumpers to actually set up the actual steppers, but you will need to configure possibly other things such as sensorless homing, and if you're using a high-powered stepper with a different power source. Now I'm going to only show you using the normal 24 volts for the entire board, but there is obviously the jumper that I just mentioned that you can use to increase the power for the board. Now obviously the power is outlined right here for the board power, and you can see there's a bed power as well as the bed power out, and they've already said what positive and negative is, which is voltage is positive and negative is ground normally. Now as you can see, they do have end stops located right in here for 6 axes. Now these may or may not be used for end stops. They may be used for other devices depending upon your tastes and preferences. And obviously they have the NEMA connections down in here for the normal NEMA 17 stepper motors that you may use. Also they have a breakout where you can use the actual breakout pins for, I believe, step dur, enable, and what is it, chip select possibly. I have to look them up to be sure. So what I'm going to do is I'm basically going to tell you about what's around the board already. Obviously we have our USB Type-C connector. We have a USB connector. Then we have a connector down here for a display. It's going to use a ZIF type connection. We also have a connection over here for USB, which I normally, or excuse me, not USB, for Wi-Fi, pardon me. And I normally don't use the Wi-Fi on my boards because I usually connect through a Raspberry Pi and use the Wi-Fi on that to communicate with it. Now down here we have our SD card that is used to load firmware. So you're going to have to format this either FAT or FAT32, and it's I believe file allocation table. And that basically says how things are allocated on the actual configuration of your SD card. So it has to be one of those two in order to use this card. Over here we have, let's see, our TFT connection. And what that is it's a touchscreen display or thin film transistor display. Next to that, we have just up above in here our red, green, black, or excuse me, red, green, blue connections that you can use for LEDs. So we may touch on that topic. Down below, over in here, we have what's known as our probe, and this can also be used for your servo if you don't choose to use a probe. These two pins over here, I believe one of them is a signal pin, one is a ground. Then of course we have our output power for our devices over in here. And these devices would be your hot end for your first hot end or hot end 0, all the way up to hot end 3 or your 4th hot end. Then up and above in here, we have what's known as our fan ports. We also have fan ports over in here that I didn't tell you about, the 2-pin connections. These though, you can adjust the voltage to the fan, so it can either be 5, 12, or 24 volts depending upon which jumper you place over here for your actual fan. Now I'll show you that in the future. Also, we have our SWD pins up in here. These are used for debug. In the factory, they may use it for loading firmware. And of course, we have newer fan pins over in here for 2 signal pins to run the higher end fans that now are coming out. And of course you can adjust the actual power to those as well up in here with these jumpers. So some of the cool stuff that we have right here, it looks like we have a multi-fan connection. That's M fan. And then we have our CAN bus, and that is believed to be control area network, but I could be wrong on that definition. It doesn't sound right for these two pins, but they're both signal pins, so that may or may not be true. Then down below, I think I've missed another type of probe in here, and essentially the 3 pins that I'm talking about are these, and I believe you can use that for either, let's see, PMP or NPN with the jumper over in here to allow you to switch between the two, but I'll have to experiment with that to let you know. And then finally we have our power detect over in here. And then there's our FWS pins. There's 4 of them up here. So first one I believe is voltage, ground, and then we have 2 signal pins. Now FWS, as far as I know at the moment, according to Big Tree Tech, means something to the effect of filament warning system, but there's 2 signal pins when you normally use only 1. So this might go to a breakout board in the future. I don't know what they're doing, but that's what it sounds like. And of course we have our PS on pins right here. And then up above, I believe there's pins for thermistors, but I don't know where they are off the top of my head. I'm gonna need to look at an actual diagram and figure that out for you. But essentially those will be used to tell temperatures. So I believe they're located up in here, and there's 5 of them. So it's basically a voltage and signal pin, and the signal I believe is, well, we'll have to figure it out by testing it, but essentially what's going on is that this will send a signal through, and depending on how fast it travels, that will be what your temperature is based on a known test pattern that they've come up before with. Then we have SPI pins up in here. So these are serial peripheral interface pins. And of course, I've covered most of the functionality that you'll see on this board. There are a couple other things like these 2 pins over here, so you can power your board with 5 volts of power. That's why I have the jumper over here. Normally, you will not use this when using high-end steppers like UART or SPI steppers, so you're probably going to leave this off when printing because it'll cause resets on your actual steppers. Now, of course, I could talk about the actual fuses that are down here, but you could actually see where they are. So I'm not going to give that away to you. But I will tell you about the processor, and this is an STM32 processor, or 32-bit processor. So I need to zoom in for a second to show you what's going on here. This is going to be highly important that you know what this is in order to load the firmware for this board. So as you can see, I'm highlighting it right now so that you can see what I'm talking about, but it's very important. So now what we'll do is we'll actually go over to my desktop and we'll try and set up the actual load for an actual firmware. So in order to do that, I'm going to have to switch views here for you. So I'm going to zoom out, go back over to my desktop, and this is what we're going to normally use. It's Visual Studio's Code, or VS Code is what most people call it. In here, we have to have the extension for Platform IO. So normal install would be you download this, install it, then you'd come in here and click on extensions, and then you'll type in something like Platform IO, and you can install it. Mine's already installed, so it's asking if I want to uninstall. In your case, if it's not installed, you'll need to install it. And then it will probably prompt you to install other things down here like you're seeing right here. But for now, we're going to ignore that. What we need to do now is understand how to get the firmware. Because this is a brand new board, we're going to have to go over to the Marlin website. So let me bring that up real quick here. So on the Marlin website, what we're going to need to do is download the newest version. This is the current version that it will work with, being 2.1.2.1. Keep in mind this is brand new and there's probably issues with it, but I'm going to show you where to download it real quick. So you're going to pull the zip file right here. And while that's pulling, this probably only is going to take a few seconds. We'll go to our downloads folder after it's completed. So what I'll do is I'll click here and I'll say show in folder. And once it's finished, this folder will pop up probably. So what we need to do is right click on it. Then we have to do extract all. Then we're going to click extract. That will extract your firmware. This is going to take a moment, so I'm going to pop back over here and show you some more stuff. So inside here, they obviously have some stuff that you can use for tools. They also have help, so you can see that there's other things here, but some of the good or interesting stuff is release notes. This will tell you what's going on with what was released in this version. So you can read through all the fixes, all the improvements, all the other stuff. And if you're still having issues, there's actually something called issues. And you can actually search on the most current open issues in here. So you can see that there is already a potential bug on this. So keep these things in mind, because this is your friend for finding a problem that may already exist and the possible solution. So now that we've got this done, I'm going to look at the manual real quick here. Here's the actual BigTreeTech Octopus Max EZ manual. Where I found this was actually when I go to the GitHub for BigTreeTech, and you click on repositories, and then you can type Octopus, and you can see it right here. Now, if you want to download it like I did, you can click on here and download the zip. This contains all the information on the board that is known at the moment. Now, I know there's currently a missing schematic for this board. I just want to warn you in advance about that. Also, there are issues that are written here just like they would be written for the actual downloads that you see for the Marlin firmware that we talked about a second ago. So you can either open an issue or you can read what the current issues are. So you can see right here there's something like Octopus Max not receiving power. This may or may not be true depending upon the person that's having the issue. I'm guessing that it's possibly true or not, but I don't know. So according to this person, I'm having trouble getting power to my Octopus Max device through the terminal connection to a Meanwell LRS 350 power supply. So this sounds like something specific to the end user. He does say that the USB works fine. I will test this, not with possibly the same power supply, but test this in the future to see if it actually works. So in my future tutorials, you'll find a link in the basics in the description where you can find what tutorials I've made in the future. Generally, I try and post things once a week, maybe a little bit longer. But keep in mind, if you want to see the stuff before it comes out on YouTube, it will be up on Patreon. So if you're a subscribed member, you can see the new stuff that I actually post. So now that we got all that done, let's go back and actually set this up. So what I'm going to have to do is click on Open Folder, and you can do that in two places. So inside here, there's an Open Folder. Then we're going to go to our Downloads folder, then our 2.1.2.1, double click, then do it again, then click Select Folder. Now I'm going to do part of this incorrect to show you something, because I made this error and you may have come across it as well. So we'll worry about that in just a second, but I'll show you the general process. Now, I normally don't use Marlin Auto Build because the functionality is exactly the same down here for Platform IO. This is just pointing to these. So I'm going to show you how to do it my way. So I'm going to first go to the Marlin folder, the source folder, the core folder, boards.h. Inside here, I'm going to search with a Control F on Octopus, and you'll see there's 6 references or 8 references for it right here actually. So we'll go down to the 7th one, and this is our board. So we'll highlight this, we'll right click and we'll copy that. Then we'll minimize here in just a second, but I want to point out that it's talking about the actual chipsets that I talked about for the STM32. These are going to be important, so you're going to have to know what these are. So I'll show you why I'm going to make a mistake. So I'm going to go over to configuration.h. I'm going to search on motherboard or scroll down to it. As you can see, here's the actual version number of the board that I was talking about. Not actually the board, but Marlin firmware, pardon me. But down here, I'm going to highlight the ramps board, and I'm going to hit Control V to paste our board type. Next, I'm going to change this to -1. Now, people will debate with me that I should do it on the next serial port, which that can be true, but I like to use this for the actual motherboard and this for the display. They're interchangeable. So I'm going to stick with the same speed that you see right here. Obviously, there may be faster speeds and maybe slower speeds, but this is the one I prefer. So now that we have that set up, we have to actually set up the environment to build. So I'm going to click on Platform I/O, and the environment in this case is going to be the default EMS or environments. So in this case, we are set to a Mega 2560, which is not our chipset. So we're going to click on the I, then we're going to find our chipset, which is STM32H7. I'm going to search on Octopus, and as you can see, it's got the EZ board right here. So as you can see, there's a chipset right here. So this looks like ours, so we'll highlight it, copy it, and then we'll minimize this. We'll go back over to Platform I/O and paste it over the Mega. So the first thing I like to do is a clean. As you can see right here, it's a little garbage can, and then I build. So you can click here and it'll clean out what you currently have. Now it's going to take a second to actually build after I click the checkbox over here. So let's click it and see what happens. I may speed this up depending upon what happens, but it's probably going to fail, and I'll show you why in a second. So as you can see, it's building along. There's no errors at the moment. If there's an actual error, it'll be in red right here. Yellow is actually a warning, and you can ignore that. So if this does fail, we'll see red. So the last time I did this in BugFix, I actually did see an error like this. And what that is it's talking about the pin numbers being incorrect. So what they're referring to is the actual breakout on the actual MCU. And the MCU is that big black thing that I called STM32. That's the microcontroller unit. So I'm going to flip back over so you can see it again. So if I go back over to the desktop, that was this right here. So as you can see, it says STM32. And then if I zoom in, we'll see even closer, and I'll highlight it again. And obviously it says STM32H723. And apparently that's what we used for the 723, but then there's a VX here, and that makes no sense. So let's go back over to the I for a second. So I'll show you what I'm talking about. So inside here, what I'm looking at is actually the configuration for STM32VX_BTT. So if we click on the actual configuration for that, you can see that there's a VET6. If we flip back real quick, let's see what we got here. VET6. So there's something off with what we're doing here. So let's scroll down a little and see if there's something else. So there's another one here that says ZX. So what I've discovered is there's something weird going on with the actual chipsets that they're using. I don't know if this is an accident where they reverse something, but obviously this doesn't work for the actual build. So we're going to go down and use this one right here and copy it. Now, obviously, it does say that it's an ARM processor, and I didn't say what the ARM processor is, so let me pop over here and first show you what's going on. So I was up here, I scrolled down, and I'm going to copy the second one. So I'm going to copy this, and it does say it's an ARM processor, which I didn't already tell you what it means. That means reduced, RISC machine. And RISC means reduced instruction set machine code, I believe, or chip. Pardon me, chip is probably what it is. It's been a while since I've had to actually explain it, but essentially it's a processor that's similar to an Apple computer processor, but in this case it's designed for something else. The actual processor for like an Intel machine would be CISC, which is complex instruction set. So you can see there's a difference that I'm trying to explain that doesn't really mean anything in this tutorial. But let me paste this in to fix it here real quick. So I'm going to go over to the INI, highlight this, paste this, and then we're going to try and build again. But I'll show you what this is that it thinks is getting all weird on you. It thinks that the actual pinouts, which are here, each one of these pins along this corresponds to a pin that's a signal pin, like PF0, that is a signal pin. PF2 is a signal pin. It's a pin that's on this actual MCU. And so it's outlined inside of here. If you go to, let's see, if we go to Marlin, then we go to source, then we go to core, we go to pins, and then we find our chipset, which is STM32H7, and then we find our actual board. You can see that this is how they make a database of which pin connects where. So you can see, if you find these pins on the board, they'll correspond to something like PF0 being your X diag pin, which is right over here. So PF0. So now hopefully that'll make sense to you. Let's rebuild this now. So I've gone off on two tangents here just so I can show you some interesting stuff, but it's to help your understanding of the actual board. So I'm going to go to the INI. I'm going to then paste what the change was. I'm going to do build again, and this should go away as an issue. If it doesn't, then I've got other issues. So this is going to take a moment to build. It's actually going to go to your .pio folder, which is in here. And as it builds, this will populate with built things. If you do get a failure at this point, normally what I like to do is do the build the second time. That way, if something builds out of order, then you can fix it possibly by doing a second build. In this case, where it failed initially, that's actually a warning that you're seeing right now. It was that I checked or used the wrong chipset. So, for the MCU. So you can see right here we have firmware.bin. So I'm going to right click on this, and this is the binary for the board. So I'm going to right click and I'm going to reveal in File Explorer. So you can see right here where the firmware is, but we have to go back over to the desktop for a second. So on the desktop, let me zoom out real quick here. I need to actually put this in the actual connection right here for my card reader and insert it in my computer where you'll hear a beep. So let's go back over to the desktop. On the desktop, I'm going to first check the drive. You can see it's empty. I'm going to go back over here, right click and say send to, and I'm going to send it to the E drive. Now you can see it here. Now if we have a problem loading our firmware where this doesn't change to firmware.cur in all capital letters, you may have to add firmware.cur as an actual file. So the trick is you go here, you type firmware.cur, and then take out the .txt, hit enter, say yes. So this is a blank file. Sometimes it checks for this. If this is not present, this may not load. So keep that in mind as a fix to this problem. So I'm going to pop this drive out and insert it into the actual board. So let's go back over to the desktop. I'm going to place it in here. Obviously, I don't normally lock the board down like I normally do. So right here is the actual loading of the MCU. I'm going to actually power it with the USB. So I'm going to have to connect this now for USB power. So I'm going to have to turn on the USB or connect it on the other side. And it just powered up. So it's loading the firmware with the flashing light for a second. And the way that we can tell that we actually made it work is to actually go over to Pronterface on the computer. So let me see if I can show you this real quick. I'm going to see if I can show you with the split screen. So give me a second here. Well, apparently it's not. Whoop, there we go. So I'm going to bring this up for you. So you can see the board. Now I'm going to try and connect, and it says port 20 as a possible connection port. Now what I want to show you real quick is if I go over to the desktop, if you don't know what the port is, you can type the following in your actual computer. So on the desktop, I'm going to type Device Manager. And inside of Device Manager, we can see what the ports are. And right here it says 23. So this is going to get interesting. So I thought it said 20. So it says 23. So let's try and connect to that. Doesn't work. So let's try 23. So we can highlight it, put 3, hopefully. See if I can backspace here. And then try and connect now. So now it says printer is now online. So there's some kind of issue inside Device Manager that's concerning, but we know that it was actually seeing it and the other one was vestigial. So let's see if we can actually test something on the board real quick. I usually like to do M119 to check end-stop status. They should be all open or triggered because there's nothing there. So let's press enter, and you can see they're triggered. So if we were to add an end stop and then do this command again, using the correct order of the pins, I have to point this out. Remember, the pins in this case are signal, ground, voltage over in here. So keep that in mind. That's what matches to the actual board. But at this moment, I'd like to thank my patrons as well as the people on PayPal for making donations to make this possible. And I'll leave links in the description to both of those places. And I want to thank everyone for taking the time to watch this video. And I'll catch up with you in the next one. So everyone, take care, be safe, remember to like and subscribe, and I'll catch up with you later.